Hey guys, hope you're doing well. We're still on multiplying and dividing rational expressions. I'm going to jump way down to almost the end to do number 8. It's got a lot going on. It's division on multiplication, so we know we're going to need to flip it. We also see two trinomials we're going to want to simplify, and I think even those binomials simplify, so we've got a lot of work to do here. If I were you, I may even do this on a separate sheet of paper. Let's go ahead and check this out though. I have A is 1, B is 7, C is 12, A is 1, so I just need an X. So I'll put my 1 times 12 is my A times B at the top, so that's 12. On the bottom I have 7. Oh no, I wrote B instead of C, didn't I? Sorry, I didn't mean to rush you. Let me even redo that. So, my magic X, I'm going to have A times C at the top. 1 times 12 is 12. I have B at the bottom, which is 7. And the numbers that work here are 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. So my top trinomial factors into x plus 4 and x plus 3. Now over on the second rational expression, I have these are different colors. You can see these apart. I have A is 3, B is 19, C is 28. So that's going to be what? My A times C, 28 times 3 is, I believe, 84. And I have 19 on the bottom. Well, what works here is going to be 12 and 7. Now, if A was 1, we'd be done factoring, but it's not 1, so we need to go into the box, right? And I'm going to have my first term, 3x squared, in the top left box. My second term, 28, I'm sorry, my constant term, 28, in the bottom right. And then these other two boxes get my 12x and 7x. Now, it's pretty obvious I don't want to put my 3x in front because then I'd have trouble making 7. So let's go ahead and put 3x up top, x in the front, and then to finish this off, x times what is 7x? X times 7 is 7x. 3x times what is 12x? 3x times 4 is 12x. So that's what this factors into over here. X plus 4 times 3x plus 7. Alrighty, so it's looking good so far. A lot of work, I know. Now on this one, the bottoms also factor, I believe. So let's check that out. I believe I can factor a 4 out of here. So 4x, and then this is 2 and 2, and then this is just 2 and 2. So like I said, what's common here? They both have a pair of 2's. So my greatest common factor would be 4. And then the leftovers, the only thing left over here is x. And there's nothing left over here. Now, when there's nothing left, we don't put 0. We actually have a 1 left over. And that's because we could always say that 4 is 4 times 1. And then something similar is going on here. 7 and x separate. 7 is prime. It doesn't break down. But again, we can think of that as 7 times 1. And then we could say what's common is 7. And what's left over is x and a positive 1. So that's how we would do that. Now, again, that's a lot of stuff. Now we want to rewrite this as a multiplication problem. But when we do that, we're going to just use our nice factored forms here. So what do I have? I end up with, on the top, x plus 4, x plus 3. On the bottom, I had 4 times x plus 1. And in the second one, when I flip it, I'm going to have 7 times x plus 1 over x plus 4 times 3x plus 7. Now, Let's go ahead and now rewrite this as one large exponential expression. I'll move the 7 to the front. And then everything else right the way you see it. X plus 4, X plus 3, X plus 1. Then on the bottom, the number's already in front. X plus 1, X plus 4, 3x plus 7. So we've already done a ton of work, right, just to get from our original problem to this form, but at least it ends really easily. The things that cancel out here are going to be what? An x plus 4 and an x plus 1. So we actually end up with a pretty nice answer. On the top, we'll have 7 times x plus 3. On the bottom, we have 4 times 3x plus 7. And that is the answer. So again, I hope you're getting used to this process. It's not particularly complicated. It's just putting together what we know about factoring with what we know about rational expressions. And let's look at that whole problem so you see all the work we did. Yeah, quite a big problem. Alrighty, see you later.